So for the first webcast, screencast for week 14 reflections, I wanted to talk about a lab I did with my students. And it was after we did the sticky tape lab. And then also, I think worksheet 1 in unit 1 of the E&M modeling sequence. I had them do this lab where we figured out the amount of charge on a piece of invisible tape, and I kind of really left it open-ended as far as the method that they would use. So they split up into groups and they were talking. And one student came up with an intriguing method. He said, voltmeter. Take a voltmeter. And what you do is you put one of the electrodes onto a charged piece of tape, and then you put the other lead onto the ground potentially with a zero potential, and see if there's a reading, a potential difference in volts. And so I couldn't really answer why that wouldn't work. So I talked to my colleague and we discussed it for a bit. And it seems that my thinking currently is that the voltage of the tape is higher than a neutral location, but the voltmeter wouldn't get a reading because there wouldn't be enough charge sustained on the piece of tape, so that there wouldn't be much of a sustained charge density imbalance to cause a force for a significant amount of time on the charges in the wire. So that's pretty much the best I could come up with. And it's interesting because the potential difference must be high, but yet we wouldn't be able to read that on the voltmeter. And then we were talking also about, well, okay, so are these voltages that are developed, these potentials that are developed on these tapes of high values? And we concluded that, yes, indeed, they would be. Since voltage is equal to the electric field strength times displacement, such that, for example, static cling, after you take clothes out of a dryer and you pull them apart, their potential difference is very high in the kilovolt range, it seems. So that suggests that you would have a very strong electric field, which could easily push around charge. And so therefore you get a current flowing and a spark generated. But as far as the idea of the voltmeter, use that to figure out the charge on the tape. That sounds interesting. I also saw in Vernier sells this charge sensor, and I'm wondering if that could be used as well to figure out the charge on the tape. So I thought I wanted to share that, and if there's any clarification that you can provide, that would be wonderful. Thanks.